So here we're going to be talking about dividing rational expressions. So just as a review, when we're dividing fractions, it is the same thing as multiplying by the reciprocal, right, of the divisor. So the divisor is always the second number in the division problem. So if I was looking at this division problem, 2/3 divided by 4/7, I could rewrite that as 2/3 times the reciprocal 7/4. And multiplication is something that we're way more familiar with and is easier to work with than division. So it's a lot nicer to rewrite this and work with it that way. We do want to simplify this, so if you're comfortable with it, you can cross reduce, but I still suggest multiplying first and then reducing. So just go ahead and multiply straight across the top, straight across the bottom. We're going to get 14 over 12, and then we want to reduce from there. So both 14 and 12 are divisible by 2, and we end up with 7/6 as our final reduced answer. So we're going to apply this idea to rational expressions to see how we can reduce them. We're going to start with dealing with rational expressions that are just monomials, and then we're going to go into rational expressions that we need to factor because they're binomials, trinomials, as well as some monomials and constants as well. So when we're working with dividing and simplifying rational expressions that are just using monomials, we're really just applying our product rule and our quotient rule of exponents. So the first thing you always want to do is rewrite as a multiplication problem. And that works the same for rational expressions as it did for your fractions, right? So we're going to leave the first one alone, 4x over y squared, change to multiplication, and take the reciprocal. So flip the numerator and denominator. 5y to the 5th is now your numerator. 6x to the 4th is now your denominator. Okay. After that, my suggestion is always multiply straight across the top, straight across the bottom, so that we can simplify when it's in a single fraction rather than trying to cross reduce, which can get a little messy. So 2, multiply. So we're going to multiply. So 4 times 5 is 20, and then times x times y to the 5th. We don't have any common bases to combine using our product rule there. Multiplying straight across the bottom. As is tradition, coefficients go in front, so that 6 is going to go in front. And then I like to go alphabetical order. So I'm going to have an x to the 4th, y squared. So that makes it nice because it keeps it simple for us when we're looking at having our y's stacked on top of each other and our x's stacked on top of each other. Our third step is to reduce. Okay, so what's helpful sometimes with the variables is if anything that doesn't have an exponent written, give it an exponent of 1 so that you remember that it does have an exponent and you need to use that when applying the quotient rule. So we're just going to simplify. So normal numbers, right? 20 over 6, that's just a normal fraction. They're both divisible by 2, so that's how we're going to simplify them. So that's really 10 over 3. X to the 1st over x to the 4th. We always take the larger exponent minus the smaller exponent, and your result ends up where the larger exponent was. So 4 is our larger exponent. It's in the denominator. So we're going to have x to the 4 minus 1 in the denominator, which is x to the 3rd. Same deal with the y's. 5 is the larger of the exponents. 5 minus 2 is 3. So we're going to have y to the 3rd in the numerator where that larger exponent was. Double check at this time that your coefficients are totally reduced. You only have one of each base. So 1y, 1x, and as long as that's true, you should be good to go and are fully reduced. So next example, we're going to do the same thing. So rewrite as a multiplication problem. So AB over C times 2C to the 5th divided by A squared. Right? We're going to multiply straight across the top, straight across the bottom. And my suggestion is always just put your variables in alphabetical order so things stay organized. So we're going to have 2, our coefficient, times a times b times c to the fifth. And then in the denominator, we're going to have our a squared times c. And now we just want to reduce. So we've rewritten as a multiplication problem. We've multiplied straight across the top, straight across the bottom, and now we want to reduce. 2, our coefficient, is just being divided by a 1 that we don't have written because we don't write coefficients of 1, so it's just going to remain a 2. We have an a to the first. Remember, write those little exponents if that helps keep track of them. A to the first over a to the second. 2 minus 1 is just 1. And our larger exponent was in the denominator, so we're going to have a to the first in the denominator, but I'm not going to write the 1 because we don't traditionally write that. B to the first is the only b there is, so it's just going to stay as it is. And we have c to the fifth over c to the first, which is going to be c to the fourth in the numerator. Okay, last example for this type. So when we're looking at this, something that's very helpful, if you don't have a denominator written, just go ahead and write one in, divided by 1, just that when we take the reciprocal, we know what's going where. So I'm going to rewrite this. We're going to have negative 15 x to the fourth y squared divided by 4z times 1 over 10xy squared. So we've rewritten as that multiplication problem. Now we want to go ahead and multiply straight across. Negative 15 x to the fourth y squared. And then divided by multiplying straight across the bottom. 4 times 10 is 40. X, y squared, z. So just writing those variables in alphabetical order just keeps us all organized and makes sure that everything works out correctly. So reducing negative 15 over 40, type it in your calculator or reduce it in your head, we're going to get negative 3/8. X to the fourth over x is x cubed in the numerator. Y squared over y squared is just 1. So remember, anything divided by itself is just 1. And then z is its only thing, so it just goes right there in the denominator. We'll put its little other tail on. And then we're all reduced. So that's reducing with monomials. Now we're going to get into reducing with division when we have binomials and trinomials. This is going to work the same as multiplication. It's the same as multiplication. It's just we have to do that extra step of writing the multiplication problem. So that's what I'm going to start doing. We're going to change it to a multiplication problem. Then we're going to factor, just like we did when we were multiplying rational expressions before, because that's all we're doing now. And then we're going to cross-reduce. So cross-reducing with factoring is a lot easier because we're not worried so much about exponents when we're looking at these problems, so it stays cleaner and more organized. All right, so I'm going to rewrite this first as a multiplication problem. 5x plus 15 divided by x squared plus 7x minus 8 times, take the reciprocal. X squared plus 10x plus 16 is now your numerator. 10x minus 25 is now your denominator. And then we just need to very carefully factor all of these polynomials. So this first one here in the numerator of the first fraction, we just need to factor out a GCF of 5. So we'll have 5 times x plus 3. And then factoring this guy, we're going to get two binomials. And we're looking for two numbers that multiply out to a negative 8 that add up to a positive 7. So we're going to have x plus 8, x minus 1 for that. Same type of factoring here for this trinomial in the numerator of our second fraction. Two numbers that multiply out to 16 that add up to 10 are 8 and 2. So we have x plus 8, x plus 2. And lastly, factoring that bottom one, we're going to factor out a GCF of 5. We're going to be left with 5x minus 5. So now we just need to cancel anything that is the same on the top that is also on the bottom here. So that's our next step. let's just move this up a little bit so we have some more space. Just a little bit more space here. Okay. So if I'm looking at this problem, I'm going to start with my 5. So I have a 5 on the top and a 5 on the bottom that we can cancel to 1. We don't have any other x plus 3's, but we have an x plus 8 over x plus 8. So remember, we're allowed to go, as long as there's 1 in the top, 1 in the bottom, and it's multiplication, it's okay if they're in different fractions. And then we don't have any x plus 2's that we can cancel. So now we just need to multiply straight across. So we have x plus 3 times x plus 2 in the numerator, and x minus 1 times 5x minus 5 in the denominator. And we're just going to leave it there. I want you to leave your answer in its most factored form. So don't distribute or multiply back together. Just leave it in its most factored form. Let's do a couple more examples. Take a look at this one. So write it as your multiplication problem. And then we're going to factor. So our numerator is going to factor in 2, let's see, x minus 5, x minus 3. Our denominator, we're going to factor out a GCF of 3, so we're going to have 3x minus 3. We can't factor a 1, it's already as factored as it can be, so we're just going to leave it there. And our denominator, we're going to factor out a GCF of 2, so we have 2x minus 5. Now we just need to cancel. X minus 5 over x minus 5 cancels to 1. X minus 3 over x minus 3 cancels to 1. Now we can multiply straight across the top. So we just have a 1 in the numerator and a 3 times 2 in the denominator, which is 6. So it reduced to just a number, a constant. All right, one more example here. So one thing that I suggested was when you see something that is going to be a multi-step factoring problem, so like this first one here, just rewrite it in its factored by factoring the GCF out real quick so that you can kind of save yourself some writing. So we'll factor that GCF out, 6 times x squared plus x minus 2. So now imagine that's in your numerator instead. And then we're just going to rewrite this as our multiplication problem. Once we have our multiplication problem, we just need to factor and cross reduce. So I'm going to finish factoring that top bit there. So we have our GCF of 6. We can factor that trinomial into x minus 1, x plus 2. Then our denominator, that's the difference of 2 perfect squares. So we're going to have 3x minus 4 and 3x plus 4. Factoring out a GCF of this guy, the 6x plus minus 8, we can factor out a GCF of 2. So we get 3x minus 4. And then x squared minus 1 is again a difference of 2 squares. So remember, 1 is a perfect square. It's just kind of the funky one. So we're going to have x minus 1, x plus 1. And now we want to reduce as much as we can. All right, so we have an x minus 1 in the numerator and an x minus 1 in the denominator. We have a 3x minus 4 in the numerator and a 3x minus 4 in the numerator, or the denominator, and that's all that we can cancel. So now we just want to multiply straight across the top, straight across the bottom, so we can get this all in one fraction. So 6 times 2 is 12, times our x plus 2. And then we have our binomial 3x plus 4 times our other binomial, x plus 1. And just double check at this time that there's nothing else to cross reduce. Now it's all a little bit more compact, and there's not, so we're good to be done.